Hey guys, Mr. Gucci here to lead you through the 1.1 notes. What is chemistry? Let's get to it. Now, I actually didn't start this unit by introducing chemistry. I wanted to start you with one of the most important concepts we're going to talk about in this class, and that is atomic theory. Now, this is something you're probably familiar with, but all matter in the world is made up of tiny, indivisible particles called atoms. Okay, atoms are the building block of all matter, and there's only about 90 different types of atoms that exist naturally. Each have their own unique properties. Some are hard, some are soft, some are solid, some are gas, some are black, some are white. Okay, they're all unique. These 90 types of atoms are called the elements. It's also what we call anything that is made entirely out of one type of atom. So, for example, this silverish black rock is a chunk of pure carbon. Okay, this rainbow colored crystal is a chunk of pure bismuth. Okay, but now clearly there's more than 90 different types of things that exist in the world, which means that we have something else that exists as well, and that is compounds, because these 90 types of atoms can combine into millions and billions of different things. All right, they join together two or more different types of atoms to form something entirely new, and that is called a compound. Now, here's an example of the size of an atom. This is actually the first picture of a single atom ever taken, and here is a penny for scale. Now, this is not actually the atom you are seeing. All right, here we go. Enhance, 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 enhance. Wipe your screen off, guys, because this little tiny white speck that I drew here represents where the atom would be. And even this little speck on your screen is about 100 times bigger than the actual atom. Okay? Again, there's about 90 types of atoms that exist naturally. Those are the elements. And this table here, the periodic table, lists them all. Okay, now I've yellowed out the elements that exist naturally but are unstable, and I've grayed out those elements that don't exist naturally and they are entirely man-made. Okay, so this is the periodic table. This is the list of all the elements, and it's going to be a very useful tool in this class because everything we do is going to be based around these 90 or so naturally occurring elements and how they attach and bond with each other. Okay, cool. Now, like I said, a compound is when two or more types of atoms combine to form something new. But just mixing them together is not going to be enough to create a compound. You actually have to have bonding take place. This is a special process by which different atoms connect to each other to become more stable. And this produces a compound. Rust is a compound produced from iron atoms and oxygen atoms. Water is a compound produced by atoms of hydrogen and oxygen, two different elements. All right, they're both gases, but when they come together, they form something that seems entirely new. All right, atoms aren't destroyed when they bond. It doesn't matter how violent the chemical reaction is, if there's an explosion or something like that. Atoms are not destroyed when they bond to each other. They just connect or detach in the exact same way that when you build a Lego set, your Lego pieces don't merge into each other. The Legos are still there. They're just connected. In the exact same way that if you smash a Lego kit, the little pieces don't disappear. They just fly apart. Okay? Now, the interesting thing about compounds is that they have properties that are very different from the elements that make them up. For example, sugar, is a white, sweet crystal, but it's made of carbon, which is a bitter black powder, and oxygen and hydrogen, which are both invisible, tasteless gases. Yet somehow, if you attach those atoms in just the right way, you get sugar. Okay? So once again, iron and oxygen, two elements that come together to form a compound, rust. And again, you know what iron is like. You've seen metal. Oxygen is a gas. Rust doesn't seem anything like that. Here's what's happening at the atomic level. Iron atoms and oxygen atoms come together under special conditions and combine to form rust. Okay? Now, chemistry, finally, what is chemistry? Chemistry is the study of physical matter, all the stuff that makes up the universe. And that means since everything is made of atoms, we're really going to be focusing on atoms and how they arrange to make all the stuff that we see and observe around us, okay? We're going to study the properties of different substances, why they combine, all right, why they don't. And this is really one of the important aspects, the most important aspect of modern chemistry, which is if we can understand why atoms combine in some ways and don't combine in other ways, if we can understand that process, then we can control how atoms combine, and we can produce all sorts of new substances that will be very useful to us. Imagine coming up with a new glass for your cell phone cover that never breaks. Imagine coming up with a chemical that, when injected into the human body, renders us immune to COVID. That's not, that's what a vaccine is. That's what a treatment is. So it's very important that we understand how atoms combine so that we can figure out how to combine them in ways that will help us. Okay? So, just another example. I bet you didn't know this. Rubies are just made of aluminum and oxygen. The same thing that you breathe combined with the foil that you put over food makes ruby, but only under specific conditions. It doesn't just happen willy-nilly. If you know how to combine them in the exact right way, then you can make rubies at home. There's YouTube videos of it. You can look it up. Okay? And you can also break stuff up in chemistry, okay? If you've ever made caramel, all that's doing is taking sugar molecules, breaking them apart into water, and the leftover pieces connect to make caramel. Okay? Now, these atoms, they combine, they form substances, okay? Substance is just the universal term that we use to describe every different arrangement of atoms, whether it's a substance made out of just one type of atom or a substance made out of different atoms bonded together. Elements and compounds, we call them all together substances. That's not just, a filler word in chemistry. Substance is a very technical word that means any unique arrangement of atoms. So if you have a block of pure iron that's just made of iron atoms, that's a substance. If you have a cup of pure water where every particle is made of H2O, that's a compound. That's also a substance. All right? Every substance has unique physical properties, innate characteristics that you can observe without destroying the substance itself. Okay? And it's through these unique properties that we can identify what a substance is. Now, physical properties, again, these are just innate characteristics you can observe while leaving the substance unchanged. Every substance is going to have a unique color. It's going to be more or less hard. It's going to have a different taste and smell. It's going to have a different density. These are just some physical properties. Other physical properties include, is it magnetic? Is it brittle? Or is it bendable? All right. Does it dissolve in water? What temperature does it melt at? Okay. Does it conduct electricity? All right. These are all physical properties, and we're going to learn more about them as the year goes on. Some things that are not physical properties, whether something is explosive or flammable, all right, that's not a physical property, because the only way to figure it out is to destroy the substance. And physical properties are just about things we can observe of a substance without irreparably changing it. All right. Another thing that's not a physical property, it's size or weight or shape. Okay. Because different substances can be made into different shape. That doesn't change what it is. For example, a pipe can be made out of iron, but so is steel wool. Steel wool is made out of iron as well. So you can't say, oh, all iron is cylinder shaped, because it's not. We can shape iron into all kinds of things. Or all gold is tiny little pieces. This piece of gold is a tiny little thing. That's not really a physical property, because gold can be large chunks as well. Okay? So at a glance, it can be hard to tell if the substance you're looking at is an element or a compound, because they all look pretty much like uniform things with unique properties. Here's how you can tell if something is an element or a compound. An element is going to be made of just one type of atom, whereas a compound is made of two or more different types of atoms bonded together. So if you know for a fact that something you see is made of more than one type of atom, it's a compound. Here's another way to tell the difference. All the elements, their names appear on the periodic table. So if you know something's name, if its name appears on the periodic table, it's an element. If its name does not appear on the periodic table, It is not an element. It might be a compound. Compounds often have complex, sciencey sounding names. If you just look at the back of a container of like something from a CVS or something, you'll look and you will see a whole bunch of ingredients. These are all compounds. Water, cetearyl alcohol, stearyl alcohol, glycerin, carbomer, dicetyl phosphate, all right, dimethicone. These are all compounds. An element, you can't break it down to anything simpler. It's already as simple as it's gonna get. Whereas a compound, you can often break it down into the elements that comprise it. Okay? So let's take a look at some possible things. All right. Sodium chloride. Is it an element or a compound? You can pause the video and guess. It is a compound, okay? Because you will not find the name sodium chloride on the periodic table. You'll see sodium and you'll see chlorine, but you won't see sodium chloride. In fact, it is a compound made of sodium atoms and chlorine atoms. All right. Next up, titanium. Is it an element or is it a compound? It's an element. You will find titanium on the periodic table. It is element number 22. Lastly, chalk, aka calcium carbonate. Is it an element or is it a compound? It is a compound, all right? It's a compound because while you'll find calcium and carbon on the periodic table, you won't find calcium carbonate. That is a compound made of more than one type of atom, okay? How about orange juice? Is orange juice an element or a compound? Orange juice is neither. Orange juice is not an element. You will not find element OJ on the periodic table. And orange juice is also not a compound. There is not one specific orange juice molecule. You can't have a chemical reaction that produces the orange juice molecule, because it turns out that orange juice is actually made out of a lot of different things, all mixed together. And we call that a mixture. A mixture is a blend of elements and compounds that are not bonded together. They're just stirred together in the same container. All right? The way you can tell that something is a mixture is that while elements and compounds have unique properties specific to just it, a mixture has the properties of the things that make it up. And in fact, by observing its properties, you can often tell what it's made of. For example, orange juice. You take a sip of orange juice, what do you sense? What can you tell? Well, one thing you can tell is that it's wet and cool. All right? So that means it probably has a bunch of water in it. It's tangy and sour. That means it probably has some kind of acid, and in fact it has citric acid, a specific acid for citrus fruits. It's sweet because clearly it contains a lot of sugar. It has orange flavor. There's actually a chemical that produces orange flavor. And lastly, it might have chunky pulp in it, all right? That is made out of cellulose, indigestible, undissolvable plant matter, okay? Now, there's two general types of solutions, okay? You have homogeneous solutions. Homogeneous solutions are mixtures of different substances that are combined uniformly so that you can't see the individual parts that make it up. An example of a homogeneous mixture would be vanilla ice cream. You look at it, it looks like one thing, but you take a taste, and what do you taste? You taste vanilla. That's vanillin, the vanilla flavor compound. You taste sugar, all right? Chock full of sugar. You taste cream. That's the fat content from the dairy. You even taste some of the milk proteins and, of course, some of the water that makes it up. If you can detect the individual substances in something that you see, it's probably a mixture. A heterogeneous mixture is substances combined unevenly so that you can see individually what makes it up. For example, Rocky Road ice cream. You can see the ribbons of fudge and marshmallow, okay? So two different kinds of mixtures are heterogeneous and homogeneous. So here's a question. Milk, what is it? It's homogeneous because it's evenly blended. It looks like just one thing. And you can't really tell what it's made of unless you take a sip and you're like, there's some water, there's some fat in here, there's some flavor. All right? Chicken noodle soup, is it homogeneous or heterogeneous? It's heterogeneous, all right? Because you can look at chicken noodle soup and you can tell what it is made of. Okay? Cool. So, fantastic, guys. Thank you. That was the notes for 1.1.